We're going to solve a system of equations right here using matrix row operations. Now we've gone over some of the details of this in class, but I'm going to go through the steps again for you here. The important points that I want you to take note of are, one, right here. This is very important. All these row operations that I'm allowed to do. There's really not that many types. I can switch any two rows. I can replace a row with a multiple of itself, as long as the multiple is not 0. And I can replace a row with itself plus a multiple of another row. Okay? So, let's go about doing that. And the order that I'm going to proceed in, once I have a matrix to start working with, is according to this chart over here. So, I encourage you to come back to this slide right here in the video as a reminder of the order that we're going and the operations on the rows that we are allowed to do. Okay, so let's dig in here. Step number 1, you first have to change this system of equations into an augmented matrix. And if you take a look at what happens, I'll circle some of the numbers so you can see how they're going here. See that -3 popped up here. This +3, there it is, and the -3 right over here. And likewise for the second row. Okay. Once you have that augmented matrix, it's time to start doing row operations. And our goal is to make it look like this, with a diagonal set of ones going from top left to bottom right. That's called the identity matrix. And once you have the identity matrix formed, your solution to the equations will be right here. So let's go ahead and do that. First thing I'm doing is replacing row 1 with row 1 divided by -3. Okay, the reason I'm choosing divided by -3 is, see that -3? I want that to be 1, not -3. So we divide the whole row by -3. Let's see what we get. -3 over -3 is 1. 3 over -3 is -1. And -3 over -3 is 1 again. The bottom part has not changed. That's still 1, -4, -2. You can see we're closer to our goal, but only a little bit closer. We've still got more work to do. Step number 2, we're going to replace row 2 of this new matrix over here, this one. We're going to replace row 2 of that matrix with row 2 minus row 1. Okay, so for every one of these calculations, I'm going to do row 2 minus row 1. 1 minus 1, well, that's going to be 0. How about next? Let's do -4 minus -1. Okay, so -4 minus -1, that's going to be -3. And then our last column right here, -2 minus 1, well, that'll be -3 again. Now, that was just row 2 getting replaced. Row 1 didn't change, so I can still keep that the way it was. And you'll see now I'm one step closer to the identity matrix on the left. I now have not only a 1 in the top left, but I have a 0 in the bottom left. That's great. Next step. Let's take this one we just did, and now I'm going to replace row 2 with row 2 divided by -3. And you might wonder, why am I doing that? Well, take a look right here. See that -3? I don't want that there. I want a 1. That's the diagonal of 1s. So to get rid of the -3, I'm going to not add 3. Remember, you can't just add numbers, but I can multiply or divide. So we're going to divide this whole row by -3. Let's see what we get. 0 divided by -3, that's easy. It's just 0. -3 divided by -3 is 1. And that's this entry also in the bottom right. And then the top row did not change. Remember, I was only replacing row 2. So the top row is still 1, -1, 1. And you see now I'm very close to the identity matrix on the left. There's just one more thing to do. Can you figure out what it is? Pause the video, see if you know the last step. Okay, did you come up with replace R1 with R1 plus R2? See, if I add these together, then I'll get a 0. That's what I'm looking for. So I'm going to add those rows together and put the result in the top row. Well, 0 plus 1, 1. -1 plus 1, 0. Bingo. And 1 plus 1, 2. I don't really care what's happening in the very rightmost set. We'll talk about that in a moment, but I didn't replace the bottom row, so that continues to stay 0, 1, 1. Okay, we're basically done. If If you take a look at this, you notice I have that diagonal of 1s that I've been talking about. That tells me I'm finished with my row operations. And what's over here are my solutions to the system of equations. So I simply say x equals 2, y equals 1. We're done. If you want, you can go back and check in the original equation, right? Plug x equals 2 and y equals 1 in here. See if you got it right. This is not a bad move, considering all the work we just went through to get this. You might as well just do a quick double check, see if you were right.